Hello, hello, can you hear me? Hello, can you hear me? Can you see the screen? Hello, can you see the screen? Tell me please. You can see. Let's start the problem yesterday last class. The problem we started. Now tell me, are you clear about the shear force? What is shear force? Tell me please. Hello. Hello. Answer me please. Are you hearing me? Shear force is like a cut. No, not shear force like a cut. You are misunderstood. Shear force, the force that is they cut the slide the cutting the shear force is the kind of the force which is the cutting force. Is work as a cutting force, right? You done now. Things is the screen is showing. Are you clear? Yesterday we did the how to calculate the shear force. Are you clear about the bending moment? How to calculate bending moment? Tell me, Hussein Jawala. Tell me. Tell me please. Draw yesterday shear force. Now we start now bending moment diagram, right? And we explain what is shear force and what is bending moment. draw shear force like this, shear force diagram, right? We draw like this, 2.5 kilonewton, 2.5 kilonewton, here minus 2.5 kilonewton, minus 2.5 kilonewton, here 0, and this was the positive side, this was the negative side, and this is called SFB. Now, I have shown you the how to draw the bending moment diagram, right? Bending moment diagram. So draw 0, 0, 0 and A, B, C. Here at a point A, our bending moment is 0. Point B is bending moment equal to area of the area of this area of the shear force diagram. So area of the shear force diagram is 2.5 into 2 is the 2, so equal to 5 kilonewton meter. So here 0, it is plus, so we go upside here. So that means here up 2 meter, right? Here is the 2.5, and we have to draw it like a incline. If it is a straight, if it is the straight like this, so you will draw the incline. Then we have plus 5 here, so plus 5, and here is at this point, from here to here, if we come to at this point, so our bending moment diagram or bending moment value will be minus 2.5 into 2, so equal to 0. So it's 0. So we'll connect the like this. So the plus. So bending moment diagram is this. So BMD. So yesterday we draw like this. Now you have any question? Tell me please. So bending moment diagram will be like this. Any question? Any question so far? If you don't have any question, then we will start the another problem. Example 7.9. The question will be like this. In the final, we'll tell nothing, just tell you draw the shear and moment diagram for the overhang beam. This is the beam. Overhang means this is the hanging portion. This is the hanging portion. This portion. This is called overhang beam. Now, first step is to calculate first reaction force. First step is to calculate the reaction force. Now, can you tell me please what is the reaction force? Can you calculate? Anyone? You can calculate the reaction force. How much the reaction force? Hello, are you there? Yes. So calculate. Can you calculate? Before calculating, are you familiar with this force? Tell me. Are you familiar with this kind of diagram? What is this telling? Ahmad Iman or Abdullah Saleh? Are you familiar? What is this? Can you tell me what is this? 4 into 2. Abdul Munaim is saying that something 4 into 2. Yes, that's true. This is called distributed load. Distributed load. This is called distributed load. The load is distributing. This is drawn in book. The place in center. Like this. In book it has been drawn like this. But when you draw in the pen or paper and have free hand, you draw like this. Like this. Okay. Like this. It means distributed load. distributed load. Okay, and this is a beam, and this is concentrated load. But if you draw beam distributed load, we draw like this, okay, by hand. But in the book they draw this distributed load. So it means the 4 kilonewton per meter. If I write down here, we want to write 2 newton per meter. That means each meter, if it is 1 meter, here work 2 newton. Here is 1 meter, 1 newton, like this. Here 1 meter, 2 newton, like this, right? 4 kilonewton per 2 newton. This means 4 kilonewton. So per 1 meter. This is the per meter, per unit length the load. But if you want to calculate the total force, then we have to multiply with 4 into 2. This 8 kilonewton will be total force. Total force is total load. We say load will be 8 kilonewton, and the load will be working at the middle. Load will be working at the middle, at the center. The 8 kilonewton will be working. So when we draw like this, as example, 5 kilonewton per meter, and we have suppose 3 meter distance. Then total load will be how much? Total load will be 15, right? Yes, 5 into 15, and this 15 will work. If you want to calculate the moment, then 15 will be work actually just middle, actually in the middle at 1.5 meter distance. At 1.5 distance, okay? At 1.5 meter distance. 15. Someone said 1.5, not 1.5. 15 distance, right? So if you're familiar, it's fine. If you don't familiar, so I have shown you. If in case you are not familiar with the distributed load. Now in exam or somewhere, we will tell you the question will be simple. Very simply, we just write nothing else. We just write down, calculate, show the shear and moment diagram. That's shear diagram. So, but at first step, you have to find the first step. You have to find the reaction force. Reaction force you have to calculate. Now, how to calculate reaction force here? You can calculate. So, if you want to calculate reaction force, it is roller. So, you will have only one reaction, and that is RB, reaction at B and vertical, right? And in A there will be two forces, right? A will be R reaction A horizontal and R A reaction vertical, right? But there is, if we calculate a summation of horizontal equal to 0, and we assume the force equal to positive, so there is RAH, we calculate RAH, and there is no other horizontal force available, right? So that's it. RAH equal to 0. That means RAH is 0. RAH is to 0, right? Now we will if you want to calculate the if we take the moment at A, point A, if we calculate moment point at A, right? So we take moment at A. So what will happen? Because RA is at the center, so it will be 0, plus RAB will also be 0. So we because passing through this point, so we can cut it out. Then we have what point? RAB, RBV, and with respect to A, it is rotating anti-clockwise. So plus into distance, we have 4 meter. We have 4 meter distance. Then what else we have? We have this force. So this is the force. The total force how much? And it will total force is 4 into 2. Total force is 4 into 2. And 4 into 2, this force will be working at the middle, at the center, at the gravity of the center. So it is 2. So it So 40 divided by 4 equal to 10 kilonewton. Let's check. Let's check the and tell me the result. Is it correct one? So our AV how much? Our AV equal to RAV equal to 10 kilonewton. Please double check and tell me the result. What is the RAV result? Tell me please. Tell me. And now if we do the summation of vertical force equal to 0 now, summation of vertical force equal to 0 and outside it positive. So what we'll get RAV plus RBV equal to 10 meter minus we have 4 into 2 minus equal to 0, right? Equal to 0. So what we have RAV equal to, so that will add equal to minus 2 or equal to minus 2. That means RBV will be negative side minus 2 A RAV, right? Now tell me, are you clear about how to calculate the reaction force? Yes, right? Yeah, so if you're clear, then we go to the next one. Next, we need to open the new slide. We open the new slide, and our beam was how much is the beam? Like this. Calculate. So 4 kilonewton per meter, and here is our forces are PV equal to 10 kilonewton, and here is downward force is, here was the hinge and here was the roller. So here was RAV equal to minus 2 kilonewton was, right? And this was 4 meter and this was 2 meter, right? This. Now our first job is we draw the shear force diagram, right? Shear diagram. In order to shear diagram, we draw a reference line like this. We draw a reference line. Okay, draw a reference line, and here is 0 0 0 0. Now, as we learned last class, right? We start with 0. Suppose we just are a point A, B, and C, right? At a point, at A, B, A, and L. Just the left side, our just here actually we don't have shear force equal to 0. So 0. Little bit right side, what we have? We have minus 2 kilonewton. That means here, just little bit here, minus 2. So minus 2 kilonewton. After this, from A to B, there is no other forces. So no other force. We will go horizontally. He is still minus 2, right? Up to where? B. We will go V little bit left. Up to left we don't have, so L kilonewton is still 2. Then BV little bit right, slightly right. We have minus 2 and minus 2, and we have what? We have just that side. That's here. Plus 10. We got plus 10. So what we have? We'll have plus 8 kilonewton. That means in this point, just imagine as plus 8 kilonewton. We go there, plus 8 kilonewton. Okay. Now imagine a middle, just some point. Suppose just we can here 2 meter distance, right? For example, we assume 1 meter distance. We're going to calculate 1 meter. At 1 meter distance, what happened? Suppose we give some name A, B, C, D at 1 meter system. Just D. So PL, how much the force? B D left side, how much we have? Here we have how much? We have plus 8. So just f in y axis. Where is f? Where is f? Where is f? Force. Yes, there is no horizontal force. We calculated before previous slide, right? Right. A R A H equal to 0. Similarly, the point we so it's just for explaining. It's just for explaining. I'm explaining it. For how much we have? We have 8 kilonewton force. And from here to here, how much force we have? How much force we have? We have 4 into 1, right? We have minus because it is working. These forces are working downward. These forces are minus 4 into 1. How much we have? Plus 4. So from here 8, from here plus we have plus 4. Okay. Now plus 4 kilonewton. See that from here to here the force is gradually working down, right? Here there was no force, so that's why we walk horizontally straight. Here we have the sum. If there is the vertical distributed force, we go inclined. We go inclined, right? Inclined line. We draw a inclined line. Okay, we draw an inclined line. Draw inclined line, right? So then again, V. Now, if we imagine now here we have okay 4 kilonewton. Then if we calculate VC, how much we have? VC we have 4 plus 4 minus from here to here equal to 4 into 1. 4 into 1 equal to 0. So we got at 0. So here to here is 0, right? So why we go like inclined downward? Because this force is working downward and distributed force. If distributed force work are you hearing me? Hello? Yes. Yes, right? Okay. If you can hear me. So here,
Doctor,
yes, tell me please.
some students have a problem with they can't enter in.
Yes, I know. I cannot do anything. I have no control about it. Okay. Hello, are you there? Okay, I think there was some problem. Now it is now I think reconnected. Right? I think it is reconnected now. Which one is learning now? Here. Okay. Uh, so as I told you, what's the problem? So as I told you, the point D actually imaginary. We don't need to think about D. We straight away can go to the C point. So this is we don't need. Just for the purpose of the explanation, I have shown you. Just for the purpose of the explanation, I have shown you, right? Now you see DC equal to, we have we have 8 here, right? So plus 8, and at the C point, if we go to the C point, so at the C point at 2 meter distance, we have minus, because the forces are working downward. So minus 4 into 2 equal to 0. So for 8 we have to directly connect to the 0. So like this, okay? So shear force diagram is already finished. This is the shear force diagram. Now someone, tell me please, do you have any question? Are you clear how we have drawn the shear force diagram? Or anyone has any question? So if you finish, now we are going to draw the bending moment diagram. Bending moment diagram. Let's draw a reference line here, 0 and 0. So here the force shear force diagram. Sorry. We draw a reference line first. We draw a reference line. Draw a reference line. First to calculate the shear force. Like I told you before, the bending moment diagram equal to just area of shear force diagram. I told you before. Now here, as point A, the bending moment is 0. Now at point B, we have point B. We go to the point B. So where we will draw the bending moment diagram? So we have, as I told you, the area, just the area. What area? This complete area. So what is the area we have? We have here -2 at moment. We say bending moment at B, bending moment at point B here, bending moment at A at this point is 0, right? B equal to, we know, as I told you, the area of the shear force diagram. So here shear force diagram is -2 here, and distance is 4. Distance is 4 meter. So into 4 equal to -8 kilonewton meter. -8 kilonewton. That means we have to draw here, somewhere here. So imagine, suppose -8 is there. So -8 kilonewton meter. Now -8 kilonewton meter. Now, as I told you before, if our shear force diagram goes the horizontally straight, our our bending moment diagram will be inclined. Bending moment diagram will be inclined. So minus 8 here. Suppose minus 8 is there, right? Minus 8. Minus 8. So our bending moment diagram will be inclined, right? Minus 8 kilonewton meter. All right. Then, oh sorry, why it is going? Okay, inclined. Okay. Then minus 8. We had here minus 8. So what is bending moment at C? Point C. So bending moment point at C equal to what we have? We have here minus 8. So minus 8, and here this is plus, right? So plus area, this area. Now we will take this area, the green area, right? The area is, this is a triangle. So half of the distance is 2. Distance is 2 into height is how much? 8. Height is 8. So 2 to cancel out, and 8 plus 8 minus 8 is cancel out, equal to 0. That means here is 0. So we will go from here to here by, we will draw, we will connect from this point to that point. But now we told that if it is horizontally straight, then we go inclined. But if it is already inclined, then how we will go? We will go the curve. The curve is like this. We will go this curve like this. Okay, we will go curve. So curve is like this. Okay, so it is completely in the downside negative. So complete side is negative. So we draw like this. We draw like this, and this is the bending moment diagram. This is the bending moment diagram. All right. So our bending moment diagram also drawn, finished. Now one thing you notice there, the bending moment diagram is maximum. Where maximum? Here, here, here. At this point is maximum value. Where is the maximum value? At this point. At this point. At this point, bending moment is maximum. The point at B. So where the point at B is bending moment is maximum. What is the maximum value of bending moment? Maximum bending moment. Bending moment maximum. Max is minus 8 kilonewton meter. Where? But where? At the place here B. So what is the special here? At the place where shear force diagram changes from minus to plus at this point. So where is the bending moment shear force diagram? Where the place, the point, the shear force diagram changes its sign from minus to plus or plus to minus, at that point always the bending moment will be maximum. Remember this, right? Remember this one, right? So I write down it for you here. At the point where shear force diagram changes its sign, SIGN, sign from positive to negative or negative to positive at this point bending moment will be maximum. Remember, this is a very important. Okay, so here our bending shear force was minus. At this point at the B, it is become plus. So similar, just exactly the same point, it is become the maximum bending moment. Okay, now do you have any question? Tell me please. Do you have any question? You have finished here. You have done, right? Our problem is solved. Tell me please. Yeah, no. What is meaning? I don't understand. First you say clear, second is no. No meaning? You don't understand? Or you have no question? Abdullah Saleh. No question. Fine, thank you. Right? Now you see there is some the way in the books it had, or the slide it had done a little bit different. Maybe I leave it for you to understand. But at the end result will be the same. At the end result will be the same. what we were writing 2 into 4 is the moment, or everything is the same. In exam, you have to just draw this and this, okay? And as I told you here, if it is the horizontally straight or constant slope, then zero slope, then we have to draw like this. And it is already their slope for the inclined, then we have to draw like this, okay?
Doctor,
Yes.
how the free body diagram for the shear force is become like this?
This one?
Like a triangle.
This one?
Yes, the right side, the triangle one.
Yeah, this. Yeah, this one, the red color, right? The blue color. This is
Yeah.
this, right?
Yes, yes.
Sorry, the blue color one, right? How become its triangle? I told you already, right? That's explained here. That's explained here. Okay, I tell you again. I will actually, I will tell you more clearly maybe next class. First, I want to teach you, and then I will do what is the trick, or no, what is the formula. I will tell you. The analytical formula is much more difficult, so that's why I want to tell you just the first main thing, and then I will teach you, right? Here you see we had 8, right? And here we had the distributed load, right? As I told you, if there is no load here, no load, so we go straight horizontally with zero slope. Slope is zero. But point here, we have what is actually happening. What is actually happening here? Try to understand what is actually happening here. Here, our original force is like this, showing like this, right? So here we have 8 kilonewton, right? So every point, if we go from this point to from B to C, if we try to work, what is happening? The every point, it is upward. It is upward. Every point is decreasing, like decreasing, right? So it was 8, then decreasing like this. That's why this, if there is no force, we go straight. If it is distributed load, we go incline down or up. If our force direction was like this, then we should go up. We should go inclinely up. Here we go inclinely down. Why inclinely down? Because from it is every point it is decreasing. Every point it is decreasing. So we go forward, right? And we connect. Then we found it is actually triangle. So clear? Clear the question? Are you clear? Okay.
So, Doctor,
Yes.
if the 10 is minus, it will be down, right?
What 10? Yes.
Think
If it is minus, then it should be minus 2. The calculation we did here, minus 2 minus 10, it will be minus 12. So we have to draw it. Then in that case, we have to draw here minus, this is reference line, right? Minus 12, okay, minus 12 like this. Any question? Do you have any other question?
no, thank you.
Sorry? So if you don't have any question, so you in the practice problem, you practice the problems given in the sheet in the uploaded or already available in the Blackboard. Now we will show you the not today because I think today will be not enough time. We have only 3 or 2 minute time. So we'll do an exercise problem to teach you, to show you all a very complicated one, right? Complicated beam. Next class. So first you see here is the hinge. We have the hinge at the pin joint. Here is the roller joint. Okay, and then we have the one concentrated load. This is called concentrated load. This is distributed load. And one external moment. External moment, right? So and distance is given. Now question will be just draw, shear, and moment. Draw, shear, and BMD. In question will be very simple. Draw, like in exam I will write like this: draw SFD and BMD. Now first step you have to find the reaction force. Then you have to like draw this and then don't know like this or this or this, whatever shear force and bending moment diagram you have to draw it, right? So if you can, now the 2 minute time we have, if you want to use this time, you can calculate the reaction force, right? First is reaction force. If your calculation of reaction force is wrong, then everything is wrong. Okay, so we don't have time today, so I expect next class we will start. Okay, do you have any other question? Tell me please. And you have the quiz next class, right? Quiz. You have quiz 2, and syllabus is chapter 5. Chapter 5, right? Yes. Okay, so you remember that. Don't forget, and should not be any other excuse. No excuse, right? No. Not MCQ. Not MCQ. Not MCQ, right? There will be one question, and you have to solve it. Solve it in detail. In detail. Okay. It will be like last quiz. Yes. And of course you must have to upload in Blackboard, not email. No email, right? And you need to keep evidence in case connection problem or any problem, any internet problem, you have to keep evidence. Okay, all right, any other question please? Inshallah. Okay, time is enough. Okay, maybe I will give you 20 minute time altogether or 15 minute time. What about the time? It is short. Yes, it is short. If you want, I can make it a short time. So, do you have any other question, please? Since you don't have today is, I think system is not working, so there is no attendance. I will give attendance to everyone next time when it will be working. So okay, thank you. So you can leave the session.